I'm Walt Disney Imagineer Asa Kalama, and I'm one of the people who design and build all the cool Disney theme park attractions, like Expedition Everest, here at Disney's Animal Kingdom. It's a high-speed train ride that takes you to the top of the mysterious Forbidden Mountain, where you come face to face with a giant creature that you've got to see to believe. And then you go backwards into the twisting and turning unknown. But I know what you're thinking. Expedition Everest? Asa, isn't this supposed to be a show about science? Well, it is. As Imagineers, we use science to tell stories, to take you to exciting places. And when you start thinking like an Imagineer, you're gonna find out that science is a lot like this. And this, and this, and this. So climb aboard and join me for a wild ride into the world of imagination, inspiration, and science. As we dream it, do it. The science of Imagineering. Wait, how big is that creature? Hello, everyone. Welcome to my workspace at Walt Disney Imagineering Research and Development, the place where imagination meets engineering. See, everything we do here begins with imagination, an idea or a concept for something that might be a whole lot of fun. Then we use the science to engineer and build bigger, better, and more exciting attractions. Okay, hang on. I'm getting a little dizzy. Much better. But there's a reason I was bouncing up and down like that. Today, we journey into the highly energetic and sometimes perplexing world of energy. But don't worry about the perplexing part. I'm gonna boil it down for you. And by the way, it takes energy to boil something too. Now, you already know that energy exists in many forms. For example, there's solar energy, there's electrical energy, and there's renewable energy. But what exactly is energy? Energy is everything. All matter in the universe has and is constantly using energy to make things happen. When a truck rolls by, when an atom splits, when your dog eats your homework, it all happens because of energy moving about. Without energy, nothing in our universe would ever change. Nothing would ever happen. In science, we define energy as the ability to do work, like moving an object over a distance. And no, I'm not talking about helping out around the house by taking out the garbage. The work we're talking about here means the transfer of energy. I know. Energy is the ability to do work. Work is the transfer of energy. It sounds like we're going around in circles. Well, we kinda are. That's because work and energy really do go hand in hand, or perhaps even club in hand. Let's say there's a caveman, and he's holding a club. Suddenly, he sees a prehistoric cave chicken. Remember, this was before cable TV. Being a typical caveman, he decides he should hit the chicken with a club. He takes aim, swings, and he invents fried chicken. But what's happened here in terms of work and energy? Let's look at it again. The caveman's club has actually done work on the chicken. It transferred its energy to the chicken to send it flying. But wait, there's more. The caveman also did work on the club by transferring energy from his muscles to the club to make it move. So, through work, energy was transferred from the caveman to the club to the prehistoric chicken. And unfortunately, to the head of his best friend Groger, who just happened to be in the wrong place at the wrong time. And yes, the chicken also did some work on Grover's head. To jump on the trampoline, I had to start by doing work. I jumped up. When I came down, I did work on the trampoline and transferred energy to the trampoline. The trampoline then transferred energy back to me. As I bounced up and down, work and energy went back and forth. And then I got dizzy. When it comes to work and energy, just remember, they're always connected. You always have to do work on an object to give it energy. And energy is constantly being transferred from thing to thing to thing. And speaking of transfer, let's go transfer ourselves to our theme parks. I want to show you how we're using the science of energy to create some very fun attractions. And trust me, this first one is gonna make your head spin. If spinning wildly is your cup of tea, then Disneyland's Mad Tea Party in Fantasyland is a classic attraction you won't want to miss. Not only are the teacups an original attraction from when Disneyland first opened in 1955, they're also a perfect example of work and energy working together. This is Imagineer Maureen Hart. Obviously, there must be some work happening to transfer energy into this attraction. Tell us what's going on.
A lot of what we Imagineers do in our theme parks involves mechanical energy, the movement of machine parts that have gears and gadgets and gizmos like ride vehicles or audio animatronics figures.
Mechanical energy is energy that an object has due to its motion or position. An object that has mechanical energy can do work. It can apply force to move another object.
On this ride, electrical energy is being transferred into mechanical energy in drive motors beneath the teacups. The drive motors work and transfer their energy to spin turntables, which in turn spin our guests.
And let's not forget about these. It's really these center steering wheels that makes this the hands-on attraction the guests love. Come on, help me spin.
It really is hands-on. We're doing work on the steering wheel, giving rotational energy to the teacup, making it spin faster and faster. So if you look at all of the energy in this system, you've got drive motors transferring energy into the turntable, and you got us transferring energy into the teacup. It's all about work and energy.
And a whole lot of fun.
Yeah!
Personally, I feel like I just put a whole lot of energy into spinning our teacup. And that raises an interesting question. Do you think the energy that I put into the system is gone? Nope, it still exists. It's just been transferred into a different form of energy.
Exactly. That's what the law of conservation of energy is all about.
The law of conservation of energy says that energy cannot be created or destroyed. It's simply converted from one form of energy to another.
And that means that the energy going into a system will always equal the energy coming out of that system.
I know you have a great light bulb example to explain this.
Yeah, think of a light bulb. It takes 100 joules, that's how we measure electrical energy, to light this 100-watt bulb every second. But when we measure the light coming out of the bulb, we only see 20 joules.
What happened to the other 80 joules?
If you've ever been close to a light bulb, you know there's heat. In this case, 80 joules of heat energy.
So the law holds true. 100 joules goes in, 100 joules goes out. Energy is conserved. Heat energy is usually the final result of the work energy process. Even here on the teacups, right?
Yeah, here on the teacups, heat energy is released as the brakes warm up and as friction occurs in the bearings and other moving parts. If you could measure it, when the ride stops, you'd see that the heat energy coming out of the ride exactly equals the energy we put into the ride.
And so energy is conserved. I gotta tell you, after all the work I put into the teacups and all this talk about heat energy, I'm ready for something cool, refreshing, and wet. The wild and watery Summit Plummet here at Walt Disney World's Blizzard Beach. It's the world's fastest free-fall body slide. And with its 12-story plunge, you can actually reach speeds over 55 miles per hour. This is Imagineer Josh Gore. Josh, walk us through what's going on in terms of energy on this attraction.
Well, actually, Asa, it all begins with walking. Come on, let's go to the top. A water slide is basically like a roller coaster. They both usually start with a giant lift hill at the beginning. But in this case, instead of using an electric motor and chain to lift a car to the top like we would on a roller coaster, here we're the ride vehicles. And we're putting our own energy into the system by climbing these stairs. So let's go. Here at the top, we've got all this stored energy just waiting for gravity to pull us down the slides.
Ah, stored energy, also known as potential energy.
Right. We have the potential, thanks to our position way up here, to let gravity do the work and pull us down the slide.
And once we start sliding down, that potential energy is transformed into kinetic energy, also known as the energy of motion. Believe it or not, all forms of energy, whether electrical, mechanical, or solar, can be in the form of potential or kinetic energy. Okay, what do you think of this idea? We know that our potential energy builds on the way up and turns into kinetic energy on the way down. Since energy is never lost, couldn't we use all that high-speed kinetic energy to launch ourselves up another hill, or 2 or 3?
Sure, let me see that. As you said, at the top of the slide, we've got all this stored potential energy. In fact, the higher the slide, the more potential energy you're putting into the system. As you slide down the slide, your potential energy drops and your kinetic energy builds. At the bottom, thanks to the pull of gravity, you're moving the fastest. So your kinetic energy is at its greatest and your potential energy is at its lowest. But hey, instead of ending there, let's take all that kinetic energy and use it to push you back up another hill. Your kinetic energy drops as your potential energy builds. But this second hill needs to be a little bit lower than the first because friction between your body and the slide and from wind resistance have taken some of the energy out of that system. Friction always resists movement and takes energy away in the form of heat. But as long as you factor in this friction, you could really add in any number of hills. You could actually even add twists, turns, and loops. You just have to make sure you start with enough potential energy to give you the kinetic energy you need so that you don't stop in the middle.
Since we're obviously going for speed here on Summit Plummet, there's a lot of kinetic energy right up to the very end. We know you can't destroy energy, so where does all that kinetic energy go?
That's where that huge splash comes in at the end. Some of the energy goes into displacing the water. That big splash also creates a lot of friction between your body and the water. The splash is kind of like a brake that takes the remaining kinetic energy out of the system and transforms it into heat energy. In fact, if you could measure it, you'd find that our bodies actually heat the water slightly here at Summit Plummet.
Cool. Or actually warm. And I think the best way to show you how this all works is to show you how it all works.
Yeah, Asa, I'm sorry, you can't slide down dressed like that.
Oh, don't worry. I came prepared. Here we go! 51 miles per hour? Now that's what I'm talking about. Energy at work. Of course, most Disney attractions don't ask you to put your own energy into the system. We try to provide that for you. And I'm happy to say, with some pretty thrilling results. Now we're really putting energy to the test. Test track here at Epcot is speeding us through one of the fastest moving rides in Disney history. Talk about your kinetic energy! This is Imagineer Derek Howard. How is energy being used to help tell a story here at Test Track?
The story behind Test Track is that you become the driver of a prototype test vehicle being put through its moves. So, unlike a roller coaster or a water slide, where gravity is often the only thing pulling you through the attraction, we need to be able to add more energy into this system to speed you up or take energy out of the system to slow you down.
And here we're using electrical energy, right?
Right. For this vehicle, the electrical energy comes from a bar beneath the track, kind of like those old electric slot cars. Electrical energy is transformed into mechanical energy inside the car's motor. The motor does work to move the wheels, giving the car kinetic energy.
The work done by electrical forces is the potential stored energy that's transferred to the kinetic moving energy of the car. So again, we have that transformation of potential to kinetic energy happening. So other than moving or stopping the vehicle, how else is electrical energy used to help tell the story?
Well, some of the energy goes into running the onboard computers which tell the vehicle what to do. Some of the energy goes into the video screens which show you what's going on, and some of the energy goes into the audio you hear in the vehicle.
And some of it goes into the last test, that whips you around the track at around 65 miles per hour. Woo! We know that the law of conservation of energy says the amount of energy going into a system always equals the amount of energy coming out. So what happens to all that last-minute high-speed kinetic energy?
Here, we use conventional friction brakes, which turns some of the kinetic energy into heat energy. Then the heat energy dissipates into the surrounding air. We're also able to do something very interesting with this vehicle's electric motor. With a switch, we turn it into a generator. As the motor generates electrical energy, it resists being turned, and that resistance works to slow the wheels down.
But on some attractions like Mission Space, a similar system generates electrical energy that we actually capture and put back on the grid to be used throughout the park.
Exactly. So Mission Space is a great example of kinetic energy going back into potential energy.
Oh, but wait, power going back onto the grid? I just remembered I'm supposed to meet someone to talk about renewable energy in 32.5 seconds. It's time to transfer some energy into me. Well, look at that. And I'm early. So, renewable energy. What is it and why is everyone talking about it? On a global level, most of our energy today comes from non-renewable sources, like oil, natural gas, and coal. Sources that can't be replenished in a short amount of time, and sources that also add lots of pollution to the environment. Renewable energy is constantly being replenished, and overall is much cleaner, like solar power, hydropower, wind, geothermal, and biomass. As Imagineers, we look for ways to design and redesign attractions to make them more energy efficient and more environmentally friendly. Check it out. This is Disney Imagineer Bruce Rao. So, tell me how some of our attractions have been built and sometimes rebuilt to be more energy efficient.
You got it. The submarines in Disneyland's Finding Nemo submarine voyage are a great example of what we've redesigned to be even more energy efficient. When they were first installed in 1959 as Disneyland's submarine voyage, all the submarines ran on petroleum diesel. When we decided to re-Imagineer the attraction, we made it a top priority to convert all of our vehicles from petroleum diesel to a cleaner, all-electric propulsion system. It's better for the environment, and it runs quieter.
And that way, you don't scare all the little fishies away. Solar panels at Epcot's Energy Pavilion. These have been up here a long time, haven't they?
They have. These have been here since the park opened in 1982. And I'm proud to say they're still converting sunlight to electrical energy for use in the park.
In 1982, solar energy was really forward-thinking, wasn't it?
Well, we were the largest non-governmental installation in the United States at the time. It was pretty much NASA and Disney.
Are we using solar panels anywhere else?
We are. We're using them at our studio lot in Burbank, California.
And since the sun is always shining in Southern California, solar energy is very renewable. So as you can see, we're not just designing our theme parks to be fun, although that is important. When it comes to energy usage, we're putting a lot of effort into going leaner, greener, and more environmentally friendly. Now, if you'll excuse me, I've got to get a running start. So, what did we learn about energy today? Well, it's definitely connected to work. You just can't transfer energy into anything without work being done on it. We also saw how energy is always switching back and forth between potential, stored energy, and kinetic, moving energy. We saw that energy can't be created or destroyed, only changed from one form to another, or transferred from one place to another. Energy can be transferred from thing to thing to thing, so the energy that goes into a system will always equal the energy coming out of the system. That's the law of conservation of energy. But there's one more attraction I want to show you today. It's back where we started. Because yes, it takes a lot of energy to climb a mountain. Come on, I know a shortcut. Expedition Everest here at Disney's Animal Kingdom is a roller coaster, so there's a lot of potential and kinetic energy going on. But as you'd expect from Disney, there's also a little something extra too. Energy! This is Imagineer Lauren Etta. Energy is being used in some pretty unique ways to help tell Expedition Everest's story.
And the story we Disney Imagineers came up with for this attraction is that right now we're standing in the remote village of Surka Zong in the northern part of India. This former tea plantation is now being run by the Himalayan Escapes Tour Company, which is offering adventure tours into the Himalayas.
Ah, But be warned, legend has it there's a giant Yeti that guards these forbidden mountains, and he doesn't much care for looky-loos. Come on, let's take our seats. Tell us about this train. It must take a lot of work to put energy into moving it.
This is the longest train in any Disney park around the world. It's 70 feet long and can hold up to 34 guests. We use electric booster wheels. They do work to transfer energy that gets the train moving.
This is a little different than most roller coasters. After the initial lift hill and buildup of potential energy, there's just a tiny downward slope.
Our creative intent was to use energy to slowly build the adventure and the excitement. This is an adventure that has to reveal itself. As the story builds, you start moving faster and faster until, well, you'll see.
Wow, that really moves. So I counted 2 lift hills, which did work to give the train potential energy. But what was going on with that broken track scene?
That's one of the most interesting ways we're using energy to add some extra thrill to this attraction. As the train climbs toward those broken tracks and your potential energy is building, we use 26 electric booster wheels to suddenly push you even higher and give you even more potential energy. But at the top, you suddenly stop. You're hanging there with all this potential energy just waiting to turn into high-speed kinetic energy. Then the brakes release and gravity plunges you backwards at lightning speed into the darkness.
Yeah, and then it happens again, right?
Right. As you're falling backwards, you suddenly go up a climb where electric booster motors once again top off your maximum potential energy. So now you're hanging there facing forward. The brakes release, and all that potential energy becomes the kinetic energy as you speed by the giant Yeti.
And I should add, the Yeti at Expedition Everest is the biggest and most powerful audio animatronics figure Walt Disney Imagineering has ever designed and built. So when he takes a swipe at you, you really feel it. Oh no! I hope you'll remember that everything starts with an idea. If you follow through with your ideas, science can be the means to turn them into reality. As we say at Imagineering, dream it, do it. Okay, one more jump to adventures unknown.
Okay, that's a wrap. Let's head home, fellas.
Guys? Guys? Anyone?